welcome our guest speaker today, Sayash Kapoor from Princeton. Thank you very much for being here with us. Also, I want to commend my friend Dan Koo, our executive director from WITSA, and Anders Halvorsen, who is our VP for policy, and also one of the big stakeholders in providing all the policy paper view that WITSA has been promoting worldwide. And this webinar, as a matter of fact, is part of the endeavor that WITSA has embraced to be one of the spokes person outfit to take the word of how important it is for us to consider all the aspects of AI. It does have an impact worldwide in all society. We just had recently the AI Summit in Rio, and there we have learned that the impact of AI is something very similar to what was the impact of the steam engine way back when, or most recently, even the internet in '94 when it became commercial. So AI does have that profound, deep impact in all dimensions of society. And of course, therefore, it needs special treatment and special care and special outlook on it. And this is what WITSA, with its mandate, to be constantly and consistently overseeing how that we in the technology sector are always promoting innovation and safeguarding everyone's rights as a universal citizen. So the webinar that we're doing today is the third. We have done two before the AI Summit in Rio. Then we had the AI Summit in Rio 3 weeks back. We're going to have this one today with Sayash Kapoor in Princeton. You're going to bring the outlook on open source AI, and how does that play into many things that are very important. One on the innovation side, the other on the safeguard and protection side. And we will keep doing these webinars because it's part of the mandate to propagate what we see is a very well-balanced position for us to have AI as the impact that the steam engine did positively in society, or as internet that we today cannot live without. And so I am going to bring now my friend Anders, who was the spearhead with me. We collaboratively worked on a policy paper that's going around the world today with our first recommendations and how we can reach that balance that helps foster innovation while at the same time safeguards our privacy and our citizens' rights. Anders, take it over, please.
Yeah, thank you very much, Robert. Appreciate it. So the WITSA policy paper was developed with the input from our membership, spanning 80 countries and regions, as well as from trusted industry partners and colleagues. So many thanks go to Robert, who is heading up our AI policy task force. As we went through the AI paper in detail during some previous webinars, I just would like to briefly show some of the key principles here. So the paper is available on the WITSA website for those who want to take a closer look. So whether the promise of AI will deliver on its potential really depends on how well businesses, AI developers, governments, and other stakeholders manage the perceived risks while fostering regulatory environment and encourages innovation, best practices, voluntary standards, and international collaboration. The recent acceleration in both the power and visibility of AI systems and growing awareness of the abilities and defects have raised fears that the technology is now advancing so quickly that it cannot be safely controlled. But as the paper explains, exaggerated and misleading concerns about the AI tool's potential to cause harm has sometimes crowded up a reasonable discussion about the technology, leading to what we call an unfortunate tech panic. So the fear that machines will steal jobs is centuries old, but new technology generally creates new jobs that will replace the ones that have been lost. Machines tend to be able to perform some tasks, not others, increasing the demand for people who can do the jobs that machines cannot. The degree of existential risk posed by AI is hotly debated, but all involves a huge amount of guesswork and a leap of today's technology. Even experts sometimes overstate the risks in their own areas. Imposing heavy regulation is an overreaction. When regulation is warranted, it is for the more near-term impacts than saving the humanity from extinction. As we all know, existing AI systems raise real concerns about bias, privacy, intellectual property rights, and as the technology continues to advance, problems could still become apparent. The key is to balance the promise of AI with a sound judgment of the actual risks and to be able to adapt accordingly, recognizing and enforcing existing rules capable of tackling harms that may arise from AI deployment before considering any new AI legislation. As the panic of new AI innovations emerge, such as generative AI, the policymakers should recognize that the predictable cycle we are in and proceed cautiously regarding any regulatory efforts so as not to harm AI innovation. The topic today on societal impact of open foundation models relates to one of the biggest tech policy debates today, as Robert mentioned, which is about the future of AI, especially the foundation models in generative AI. Open source AI provides an important pathway for innovation since anyone can freely use and modify the code and data for research and commercial purposes. Developers can contribute to an open source project or create their own based on existing project. By sharing code and data, this collaborative process accelerates development, cuts costs, and democratizes access to AI technology. For example, developers can fine-tune open source AI models for specific applications and thereby facilitating adoption. Open source AI not only enables research and development on more capable AI models, but also progresses on other metrics such as explainability, bias.
These slides are not moving.
Yeah, well, I'm so sorry. Yeah, I am nearly finished anyway. So it was just a very quick summary of these slides. Should OpenAI models be restricted? This question is central to several policy efforts like the EU AI Act and the US Executive Order on Safe, Secure, and Trustworthy AI. In this talk, Sayash Kapoor will discuss the benefits and risks of open foundation models and introduce a framework to assess the marginal risks compared to the closed models or existing technology. The framework helps explain why the marginal risks is low in some cases, clarifies disagreements in the past studies by revealing the different assumptions about risk, and can help foster a more constructive debate going forward. Sayash Kapoor is currently co-authoring a book titled AI Snake Oil with Arvind Narayan, which provides critical analysis of AI capabilities, separating the hype from the true advances. His research examines the societal impacts of artificial intelligence with a focus on reproducibility, transparency, and accountability in AI systems. His work has been recognized with various awards, including a Best Paper Award, ACM Fact, an important recognition award at ACM CSCW, and inclusion in Time's inaugural list of the 100 most influential people in AI. Sayash, it's a pleasure to welcome you to this webinar, and we appreciate you taking the time to educate our membership on this important topic. Following your presentation, we have invited Dr. Mike Nelson, who is a Senior Fellow of Technology of International Affairs Program at the Carnegie Endowment for National Peace, to make a few comments, and we will open for a few questions from the moderator and audience as the time will allow. Thank you, Sayash. It's over to you.
Thank you so much for having me. It's a pleasure to be here with all of you. If possible, could you allow screen sharing?
Yes, of course. I just make you a co-host, so go ahead.
Great. Are my slides visible okay?
You can see them fine, thank you.
Perfect. Thank you so much, Anders, for having me here. It's a pleasure to be in conversation with you all. As has been mentioned, today I'll be talking to you all about the societal impact of open foundation models. So most of the talk is based on a position paper that we wrote recently here at Princeton University. The paper was written mainly in collaboration with various groups at Stanford including the Center for Research on Foundation Models, the Stanford Center for Human-Centered Artificial Intelligence, and the Stanford Lab on Regulation, Evaluation, and Governance. Now, apart from these sort of two universities that led the paper, there were a number of other organizations from the industry, including organizations like Meta and Hugging Face, from civil society, including the Center for Democracy and Technology, as well as the Open Source Initiative, and of course from academia, who were all involved in the writing of this paper. And the slides here list the complete list of authors on the paper. Okay, so before we get into the meat of the paper, I think it's very important to start from definitions. So what do we mean when we say open foundation models? So as you can see, there are three parts to the term. There's open, foundation, and models. So let's start with what are foundation models. So back in 2021, one of my co-authors, Rishi Bomasani, wrote a paper titled The Opportunities and Risks of Foundation Models. And this is a figure that is cited from that paper. Foundation models are essentially models that are trained on broad amounts of data, including language models that are trained on the internet, or vision models such as text-to-image models that are trained on images, and so on. And the key part about foundation models is that they can be adapted for a large number of downstream tasks. So you build one model that can be used for many tasks. For example, today we can use models like GPT-4, which powers ChatGPT, in order to do question answering or sentiment analysis or information extraction and so on. So this is the definition of foundation model that we're looking at. We're looking at models that are trained on a broad amount of data and can be used for many different downstream purposes. Okay, so now that we've talked about foundation models, what constitutes open foundation models? And the reason I stress this definitional importance is because open foundation models are different from open source software. So when software is released open source, it means that there are a few different things available. The software itself is made available. There are no use restrictions on the software, which means that you can modify it in any way that you please. And the entire source code for creating the software is also made available together with it. Now, if we go by this definition of what constitutes open source AI, then a lot of the models which we consider open would not fall under the definition. And here's why. So one of the models that has seen the most adoption in the last few years is Meta's Llama series of models. The thing that's made available alongside the model's release is the model weights themselves. So this is essentially the same as having a piece of software that has been released openly, but not the code. Because Meta did not really release any code artifacts or documentation, or even the data that was used to train the Llama 2 series of models, alongside its release of the model weights themselves. But we still consider these models open because the model weights are available for download and reuse. And in particular, we think of openness as a spectrum instead of a binary decision of what makes a model open source. So on the slide here, we have the entire spectrum of the model. Basically, on the left-hand side, we have fully closed models. These are models that might never see the light of day outside a particular organization. So for example, Google released a paper talking about the Flamingo series of models. This model was never released to anyone. Like, you cannot use the model if you're not at Google. This model is essentially behind like a restricted access. Then if we move a bit along the spectrum, we see models like GPT-4 and GPT 3.5. These models are not made available in the sense that the model weights are not available for anyone to download, but they are available in the sense that you can use these models from a user interface, or something like ChatGPT, or you can use an API to query them. An API is basically an application programming interface that allows programmers to use these models from their code. So these are also models that we do not consider open, simply because OpenAI can revoke access to these models at any point of time. So access to these models is predicated on OpenAI allowing people to access them. And so, for instance, OpenAI has in the past rolled back access to certain models that have been very popular, both in academic research as well as in other domains such as the industry. So these basically constitute the set of models that we call closed. And in stark opposition to these models, we have open foundation models, which are basically made available. So the weights can be downloaded by a large segment of the public. Crucially, once these weights are downloaded, you cannot revoke access to these weights simply because people already have access to the weights. And as you see along the spectrum, so on the leftmost side of the open foundation model space, we have models like Meta's Llama 2. We also have Big Science's Bloom. So this model was released with the weights, but also the data and the code used to train the model. But it did have use restrictions. So there were certain things that you could and couldn't use the model for. And that essentially makes it not really an open source model. And then on the rightmost side of the spectrum, we have what we can essentially call open source foundation models. So an organization called Eleuther AI released a model called GPT Neo X, where the weights of the model, the data used to train it, as well as the code used to train the model was available. And all of these things were available without any use restrictions. So downstream actors could decide what they want to use the models for, and they wouldn't really be bound by any restrictions in the license. Okay, so this sort of covers the definition of like what open foundation models mean. And finally, I want to stress again that a definition of open foundation models focuses on the model weights alone. So it does not focus on other artifacts like the code used to train the model, the data used to train the model, and so on. And I'll come back to why we chose this definition in a minute, but essentially the main reason is that much of the debate around the benefits and risks of openness hinges around the irrevocability of open foundation model weights. So in other words, people are concerned that once you release the model weights openly, there are no takebacks. And so the reason we focused on the definition of open model weights is precisely because we wanted to respond to this concern. Okay, so having talked about what constitutes open foundation models, let's look at a few examples. So this slide in particular lists notable examples of the types of open foundation models that we are talking about. In particular, in the last few years, I've seen a trend where people conflate generative AI with foundation models. And I just wanted to point out that that's not definitely the case. So basically, models like Clip and BERT, which are models that are not generative, and yet can be used for many downstream tasks and can be sort of adapted for many downstream tasks, are still examples of foundation models. Because remember, the definition of foundation models is that models can be adapted and fine-tuned for a wide variety of tasks and need to be trained on broad data. And so to that extent, many models might not be generative. They're not really generating text or images and other media, but they're still examples of foundation models, and specifically open foundation models, because the model weights can be downloaded. Okay, so in the intro to this session, we heard a little bit about why focus on open foundation models. I wanted to go in a bit more detail about why we chose to focus on open foundation models. So in the last year or so, we have seen a lot of concerns around releasing foundation model weights openly in all sorts of areas. So in research, this is an example of a paper that was released from MIT. The paper is titled, "Will releasing the weights of future language models grant widespread access to pandemic agents?" Essentially, the main argument of the paper is that if we continue to release models like Llama 2 openly, in the future, we'll have models, excuse me, models that can cause pandemics because people might use these language models in order to learn how to create pathogens. And on this basis, the paper argues for restricting the release of open foundation models. Now, this is just one of many examples. We've seen such examples come in many different domains, including many of the ones we'll see later in the slides. But it's not just that these are research papers or academics making an argument. We've already seen a lot of impact from this line of research on policymaking. So as was mentioned earlier, the two notable examples are the executive order on safe, secure, and trustworthy artificial intelligence from the United States White House last year. And in particular, the section 4.6 of the EO solicits input specifically on what they call dual-use foundation models with widely available model weights, which essentially boils down to our definition of open foundation models. Here, the executive order is looking for inputs on how these models should be regulated, how the risks can be mitigated, and so on. And similarly, the European Union also has carve-outs for what they call open source or free and open source licenses and models that are released under free and open source licenses. And a lot of this debate is centered around reducing the risk from these models. So this is just to say that, all of this research and all of the claims around how dangerous open foundation models are being taken seriously by some very important stakeholders. Finally, we've also seen a lot of coverage for open foundation models in the media. So this is an article from Time magazine on the heated debate over who should control access to AI. And once again, this is one of many examples of how open foundation models have really become like this topic of intense debate. So in our work, we wanted to sort of step back a little bit and understand what the real risks are even. And I think it's very clear from the last few slides that the debate has become really polarized. And so one of our concerns was that, in this process of polarization, we sort of lose the ability to understand even the other side's arguments. So in order to have space for a more reasoned debate, we started out by looking at the distinctive properties of open foundation models. Or in other words, what is it that leads to both the benefits as well as the risks of openness? In particular, we found there are 5 such properties. The first is open foundation models, by definition, mean that there's a broader range of people who can access the models. So unlike OpenAI's ChatGPT, where OpenAI can enforce use restrictions, it can ban people's accounts, it can stop access to the model entirely. Unlike this type of closed model, open models are essentially available publicly. And so that means that restrictions are really hard to enforce. So we saw this with Meta's release of the Llama 1 models. This was, I think, back in March 2023. When Meta released the model, it was initially only open to researchers who had to fill out a whole form. But very quickly after the model was downloaded by these researchers, the model's weights were leaked online. And so essentially, the restriction that Meta tried to impose on this model was also really hard to impose. Okay, the second property of open foundation models is that they offer far greater customizability compared to any closed model. So this can include things like fine-tuning, where a model can be fine-tuned to perform a very specific task, and it can be fine-tuned by basically anyone. Like fine-tuning a model is much cheaper than training it from scratch. It also has led to many other customizations. So things like custom decoding, which basically refers to how a language model generates outputs. And this can include things like adding watermarks so that you can recognize what content was created from your language model. And this also includes things like quantization. In the last 6 months or so, quantization has enabled language models to run on much smaller hardware, much more efficiently. And this was only possible because the language model's weights have been made available publicly. And so researchers could simply download these weights and do research on how to run these models more efficiently, which also means that they're reducing the costs for adopting these models, sometimes by orders of magnitude. A third distinctive property that we identified was that open foundation models can be run locally. So essentially, these foundation models can be run on the hardware of your choice. And as we'll see later, this becomes really important when you're dealing with private or sensitive data. Essentially, in domains like healthcare or finance, you do not want to send your data to a third-party server. You, for instance, don't want to make an API call to OpenAI servers, because that means that confidential data would then go to OpenAI. So if there are strong privacy requirements, open foundation models are really important to enable this model to run on your hardware instead of your data going to a third party. The fourth property is, as I mentioned earlier, it's very hard to prevent access to the model once the models have been released. One example is Meta's sort of hurdles with their Llama 1 series of models. But increasingly, we are seeing academic torrent websites where models are being released. So here's an example from the French AI company Mistral, which has this trend of releasing models openly on peer-to-peer torrent websites. And once a model has been released on such a website, it's essentially impossible to revoke access to the model. And finally, the last property, which sort of follows from property 4, is that we can't really monitor or moderate access to these models. So in other words, when we have closed models like OpenAI's GPT-4 or Anthropic's Claude, both of these companies can take measures to look at what people are using these models for. And if they are using them for illicit purposes, things like generating malware or cybersecurity threats and so on, they can revoke access to these models. But for open foundation models, precisely because these models can run on someone's local hardware. In fact, some of these models can even run on like your MacBook. It's really hard to monitor what these models are being used for. And so as a result, it's really hard to moderate usage and to sort of prevent certain types of harmful outputs. Okay, so having identified these sort of 5 distinctive properties of open foundation models, we then sort of did the work of connecting them to various benefits as well as purported risks of openness. And in particular, our hope was that having identified these distinctive properties, we can get some more consensus on the specific benefits that we outline, but also it clarifies why we are arguing for the specific benefits that we think about. Okay, so with that said, let's come to the benefits of open foundation models. Specifically, we look at how the benefits of open foundation models arise in relation to these distinctive properties. Okay, so one of the sort of main benefits of open foundation models is that they distribute who defines acceptable model behavior. So here's what I mean by that. Models like GPT-4 and Claude have very specific guardrails which determine what these models can and cannot be used for. So in particular, you might have encountered, if you use ChatGPT, even a benign query might be answered from the model, might be answered by a response like, as an AI language model, this goes against my guardrails. I think lots of people have reported seeing incorrect refusals, so refusals to benign queries. In contrast, when model weights are released openly, we also distribute the power of defining acceptable model behavior. And that's because many different people can access the models, but they can also fine-tune the models to their specific tasks. So here's an example. Some of our collaborators at Stanford wanted to use language models to identify how toxic behavior arises on the internet. And so in order to do this, they basically wanted to use language models so that they did not have to like make real humans read toxic behavior. But at the same time, they could not use OpenAI's models simply because you can't simulate toxic behavior, even if it is for this benign purpose or for this research project, simply because the model would refuse to answer. And so they ended up using open models that were fine-tuned for their specific tasks. And that was how they sort of went ahead with the research study. Now, this is not the only example. You might think of various examples where you want to customize model behaviors in ways that OpenAI would not allow. For example, you might want to, like for someone who's writing fiction, they might want the model to be as realistic as possible or use profanity or whatever. And all of those are things you cannot really do with closed foundation models at all. So this is just an example of how severe some of these guardrails on closed models can be, even for legitimate users. All right. The next sort of benefit that we highlight is increasing innovation. Open foundation models can be very aggressively customized through things like custom decoding and quantization. And so because of that, they better support innovation across a wide range of applications. So as we discussed earlier, one of these applications is anything that's that involves sensitive or private data that you don't want to send to a third-party server. Because open foundation models can be run locally, they allow these models or these types of applications, which are privacy sensitive, to occur or to happen on local hardware. Similarly, like in many cases, the customizability of open models allows improvements, like being able to fine-tune the models on your specific data often leads to much better performance compared to if you didn't fine-tune the model. A third benefit of open foundation models that we highlight is accelerating science. And in particular, we outlined this sort of small list of papers that have resulted from the use of open foundation models. This list is non-exhaustive. There are hundreds of papers that have resulted, and these are just like a small slice of what has resulted. But essentially, for many types of academic research, having access to foundation model weights is necessary. And this includes the type of research that makes AI safer. So you'll see, at least at the top of the list, we have many examples of safety and security, alignment, as well as privacy research that relies on the weights of open foundation models to make AI models safer. In many cases, these insights have also led to closed models, making their own sort of safety guardrails better. And so hopefully this highlights that the availability of model weights has led to many advances, not just in AI research, but also in very diverse fields like brain imaging analysis, medical applications, computer architecture, and so on. Now, I will say that there is one caveat listed at the bottom right of the slide, which is that foundation model weights alone are not enough for all types of research. So our definition, if you recall, of open foundation models is that the foundation model weights are made available broadly. But some types of academic research also require access to the training data as well as the code. And so in that sense, the further along the spectrum we move towards openness, the more we realize these benefits to science. Okay, so moving on. So our next and last main category of benefits from open foundation models is enabling transparency. And in particular, I highlight results from our collaborators on the 2023 Foundation Model Transparency Index. So the Foundation Model Transparency Index basically looked at how transparent AI developers are about various aspects of how they train their models. So this includes the data that they use to train the models, how much they sort of think about the model architecture, or what they release in terms of downstream documentation. And all of these sort of various types of transparency requirements were posed as indicators for this index. And we found that out of a score of 100, first, the transparency is notably absent from the ecosystem. So even the best model scores around 50%. But second, open foundation models did much better compared to their closed counterparts. So in particular, you'll see that 3 of the top 4 models in this case are open. Meta's Llama 2, Big Science's Bloom Z, and Stability AI's Stable Diffusion are all examples of open foundation models. And so open foundation models can enable lots of transparency about how these models are being developed. And in particular, this can sort of lead to more insights in like innovation and science. It's almost like a requirement for many of the other benefits that we see from openness. Now, once again, there's an asterisk on the top of this benefit, which is that the availability of other assets, in particular of training data, the code, but also documentation about how the models were trained, would further improve transparency. Okay, so this brings us to sort of a brief end to the discussion on the benefits of open foundation models. Now let's move on to the risks of foundation models, and in particular, how these risks arise in relation to the distinctive properties of foundation models that we've discussed. So now, as I've mentioned a couple of times already, I think the main reason for these risks arising is that broader and irrevocable access to models often leads to concerns that we can't really sort of rescind access, we can't monitor or moderate these uses. And in particular, this type of concern has led to a vast number of people sort of arguing against the release of open foundation models. So we've seen one example already. This was the MIT study that said foundation models can be used for like creating bioweapons, essentially, or pathogens. But it turns out that the claims in the study might be slightly overstated. So in a follow-up paper from like a different group at Stanford, they basically looked at what information was made available through the in this MIT study, and what was this like extremely dangerous information about building pathogens that was enabled by open foundation models. What they found was that it's true that open foundation models can answer some questions about building pathogens. But if you ask those same questions on Wikipedia, or if you use substantially similar search terms on Wikipedia or on like a search engine such as Google, you get very similar information as this MIT paper. So in particular, the crucial error made in this analysis from MIT is that they did not consider the marginal risk or the incremental risk of releasing models openly when it comes to creating bioweapons. If we can find the exact same information on creating bioweapons on Wikipedia, then if we followed like the recommendations outlined by the paper itself, would that mean like we ban Wikipedia? Would that mean we ban a lot of scientific research? I hope not. And so this essential insight basically led us to create a framework for how we can carry out these risk assessments properly. And in particular, we wanted to focus on how we can evaluate the marginal or the incremental risk of releasing a foundation model openly, because essentially that's the property at stake when we are considering policies to ban open foundation models, or when we are considering policies to restrict their releases. What we really want to know is how risky these models are compared to existing technologies such as web search on the internet, and even compared to releasing these models in a closed way. So based around this insight, we came up with this framework for assessing the risks of open foundation models. It's a 6-step framework. I'll walk through each of these steps very quickly, and then we'll dive into 2 case studies of how we can use this framework in practice. So the first step of the framework is sort of basic. It's basically about specifying what specific risk we are analyzing, but also about who this risk is from. So I think the second part of this question is sometimes underappreciated because, for instance, if you're talking about the cybersecurity risks of open foundation models, it differs very greatly based on who the risk is from. If it's from like a small group of hackers or perhaps even people who don't really have formal training, the risk is very different compared to if a state-sponsored hacker is using open foundation models to cause cybersecurity incidents. The second and the third steps are about acknowledging that in many cases, the risks that we're concerned about are already risks in the real world, even if we forget about open foundation models. And so the second and the third step basically ask people who are conducting the risk assessment to talk about what the existing risk is, absent the use of foundation models, and specifically absent the use of open foundation models. And similarly, because these risks already exist in the world, what are the existing defenses? So for something like biosecurity attacks, we do have some existing defenses in the form of the screening materials, or basically screening who gets access to DNA synthesis machines, what materials are being sold to people, and so on. So what these existing defenses are can tell us a lot about how we've dealt with the problem in the past. Now, having done this base level analysis, I think we get to the crux of this risk assessment framework, which is the marginal risk of open foundation models. And in particular, we ask people to think about the marginal risk compared to both existing technology, such as web search on the internet, but also compared to closed foundation models, because as I mentioned, many of the policy proposals are specifically focused on banning or restricting the release of open foundation models. So we really need to be precise about what is it that releasing model weights openly leads to, that not releasing them openly, but perhaps in the way OpenAI does, would not. Having done some sort of analysis of marginal risk, I think it's also important to think about how difficult it is to defend against this marginal risk. So in some cases, we might find that there is some marginal risk of releasing models openly, but that this risk is very easy to defend against. In others, we might find that it's actually really hard to defend against the marginal risk of open FMs. And so we might think about what the most effective interventions would be. And finally, the last stage of the risk assessment framework is underlining and basically putting out what the uncertainties and assumptions are in this analysis. Going back to the beginning of the presentation, one of the main sort of motivations for carrying out this or building this risk assessment framework is to allow people who have very different opinions on the topic to be able to communicate with each other. And so outlining what people are assuming in their analysis, things like how the capabilities of models will improve, or what they're uncertain about, can essentially make this process easier. But it also helps us outline where sort of the analysis might be most applicable and where the results of the analysis might be uncertain. So now, as I've mentioned a couple of times, I think we had a few different reasons for building this risk assessment framework. The first was just providing a common vocabulary that clarifies what risks are under consideration. Because if we don't really have an understanding of what we're trying to calculate, which is the marginal risk, then one side might say that, look, open foundation models can tell us how to create bioweapons, whereas the other side might say this information is already available on the internet. And basically, these two sides are talking past each other. So the vocabulary of marginal risk essentially provides this common ground for people to realistically assess what the risks of releasing models openly are. More importantly, I think the pipeline of risks help us focus on the entire system that is being used for creating this risk, rather than just interventions at the level of the model. Because oftentimes it's not enough that you have access to a model to realize a risk in the real world. For example, in the bioweapons example, let's say Llama 2 gives a lot of information about how to create a bioweapon to someone who's using that model for causing harm in the real world. It's not really enough to get that information. After this point, this person basically needs to acquire the materials, acquire the knowledge of how to use these materials to create bioweapons, basically have access to a wet lab where they can experiment, avoid getting themselves infected, and then release this pandemic-causing pathogen to the world. Now, this basically also points out that there are many different points of intervention that we can take. So we can strengthen our existing screening mechanisms rather than taking actions at the model level. We can sort of look at what downstream interventions might be most effective. And I think this also gives us a better sense of how we can prevent these risks. Because in the AI community so far, it's often thought that restricting access to models is the best intervention, whereas we don't think that's always necessarily the case. In fact, we think in a lot of cases, the best interventions lie downstream. And then, as I mentioned, I think researchers and analysts who have very different priors can communicate better with each other. And also, this risk assessment framework can help us sort of keep track of the risks as the capabilities of open models increase. So as Anders mentioned at the start of the call, I think there is a lot of speculation about what the capabilities of future language models and future foundation models would be. And I think something like this framework can help us keep track of where we actually need to take action versus where we are basing our analysis on speculation. Okay, so this hopefully gives you an idea of what we wanted to go for with the risk assessment framework. Now, having come up with the framework, the next thing we did was we looked at past papers that had claimed to analyze the risks of openness and tried to analyze how many of these papers fulfill which of the risk assessment steps. So in particular, we looked at 7 of the most commonly cited risks of open foundation models. These range from scams, like voice cloning scams or spear phishing scams on email, to cybersecurity risks, biosecurity risks, risks of disinformation, as well as image-based harms, things like non-consensual intimate imagery or AI-generated deepfakes, as well as child sexual abuse material. So these are 7 of the most commonly cited risks of open foundation models. And on the table to the right, we basically looked at whether the papers that were making these claims followed different steps of our risk assessment framework. What we found was that for 6 of these 7 risks, essentially the papers did not really do a good job of analyzing the marginal risk of open foundation models. The only paper that we found that did a reasonable job of analyzing the marginal risk of openness was in the last column. Thiel et al. In 2023 wrote about how openness can lead to an increase in the creation of CSAM. And we'll get to some of this analysis in a minute. But basically, I hope this shows that for many of the risks that we talk about most, things like biosecurity, cybersecurity, as well as disinformation, we really have very little empirical evidence that open foundation models substantially increase the risks in the real world. Okay, so having come up with this framework and having done this empirical analysis, we also then wanted to do our own analysis of what the marginal risk of openness is. And I'll now talk about 2 different risks that we looked at. In one case, we found that openness does lead to an increase in the marginal risk. But also in that case, I think it's very hard to sort of restrict openness, or restricting openness will not really lead to a reduction in the marginal risk. In the other case, we found that openness does not really increase the marginal risk. And in fact, many claims that it does might actually be premature or misguided. So the first case study is the second last column in this table, which is non-consensual intimate imagery, or NCII. And the second case study is cybersecurity. And we'll get to both of those in turn. Okay, so let's start with NCII. The way I'll proceed is just by going over all the 6 steps of the risk assessment framework for both of these risks. So the first step of the framework is threat identification, that we need to identify what the risk is and from whom. So in particular, the threat we identify is that digital tools can be used to alter images of people to create AI-generated deepfakes. Typically, the threat actors, or the people who are carrying out this risk, are people who are individuals, or sometimes we've also seen this behavior occur on coordinated groups. This includes online platforms, in particular Reddit, as well as Telegram. And then coming back to targets, so most of the times the targets are private individuals, but often we also see public figures being targeted by AI-generated NCII. So absent open foundation models, we do have some existing risk. Photoshop has been used to create digitally altered NCII for a long time. And even without foundation models in the last sort of decade or so, we've seen many sorts of face swapping or rudimentary machine learning techniques that have been used for creating NCII. And it's not just that these images are sort of used and posted online. Sometimes they're also used for extorting people, in addition to the emotional and psychological tolls on the victims. We have developed a few defenses for AI-generated NCII over the years. So one thing that makes defenses hard is that this software can mostly run on consumer-grade devices. It can run on your laptop, it can run on your cell phone, and that it has proliferated widely. Note that we're still talking about existing defenses, which are like defenses for the case where we don't yet have access to open foundation models. And so there have been some efforts within the open source community to stop the sort of use of these tools for NCII, but so far they have not been sufficient. But some of the sort of most effective interventions in this case have been downstream, in particular on online platforms where NCII is distributed, such as Facebook, Instagram, YouTube. And one example of a successful or a somewhat successful effort is a nonprofit called stopncii.org. So what this nonprofit does is, if you fear that some piece of NCII about you is proliferating online, you can report it to stopncii.org. They add it to like a centralized database. And essentially, as soon as that piece of NCII is uploaded to any of the participating social media platforms, and I think they participate with like over a dozen platforms at this point, if it's uploaded to any of these dozen platforms, the piece of media is automatically taken down. Okay, so now having understood what the existing state of affairs is, let's look at what the evidence of marginal risk of open foundation models is. So compared to previous tools like Photoshop, open foundation models can be fine-tuned to create models for creating NCII about specific people. And in particular, we've seen these models proliferate online. And also compared to Photoshop, it's much easier for non-experts to be able to use these models. Further, because these model weights are available publicly, the guardrails on open foundation models can be easily circumvented. So an example of this is when the open text-to-image model Stable Diffusion was released widely on the internet. Within a few weeks, many of the guardrails against creating NSFW content were removed. And perhaps as a result of that, we've seen several real-world incidents that show the clear harm of releasing these models openly. Now, one natural response to this analysis so far might be that we can restrict the release of open foundation models going forward. But we think that non-proliferation of these models is not feasible. And that's particularly because many of these models require very few resources to run. They're already available on the internet. And so even if we ban text-to-image models going forward, the models that have currently been developed will continue to be used for this purpose. In contrast, one of the things that we think is warranted is crackdowns on the distribution of these types of specifically tailored models. So one example is this organization called Civit AI. So Civit AI is a startup that enables people to share models created on like open foundation models. And specifically, they also allow people to solicit models that output images about specific people. So I think this downstream layer of intervention might be much more effective at curbing the harm of AI-generated NCII compared to restrictions on models alone. Another thing that will help is clarifying the legal status of AI-generated deepfakes. So far, I think this is a bit of a legal gray area. In particular, in several cases going back to the 90s, in the United States, the Supreme Court ruled that virtual pornography is protected under the First Amendment. And so I think as we've seen these models become more effective at creating NCII about specific people, making improvements in the legal status of AI-generated NCII and more clarity on whether that's allowed or not, I think would be much more effective. But at the same time, I think it's important to acknowledge that a lot of this type of legislative or policy action might be fundamentally ineffective because much of the spread of AI-generated NCII happens on end-to-end encrypted platforms, things like Signal or Telegram, and it's very hard to police these platforms. Okay, coming to the last step. So what are the uncertainties and assumptions in our analysis? So the first assumption is that technical solutions for curtailing the use of existing models to create NCII would be hard or impossible. And I think the reason we make this assumption is because we can already run these models on a laptop. Even if we can have technical safeguards on future models, it's really hard to have them on present models. Basically, it's very hard to sort of develop this type of robust infrastructure. And then one of the key things we highlight is that even if people follow these recommendations of taking action on downstream platforms like Civit AI or Facebook or Instagram, we'll still have anonymous and end-to-end encrypted channels that can still continue to be misused. Okay, so this brings us to the end of the first case study, where we found that the marginal risk of models is high, but also that restricting releases of open foundation models will likely do very little to curb the harms of creating these models. A separate case study, the second one that we do in our paper, consists of cybersecurity. So here, one of the main things that has been outlined is that language models are really good at writing all sorts of code. And as a result, people who are malicious users or hackers can use these to detect vulnerabilities in critical infrastructure and to exploit those vulnerabilities in order to get inside these systems. So in particular, the key threat we look at is automated vulnerability detection. And the threat actors can include a wide range of actors. It can include individual hackers, small groups, as well as state-sponsored attackers. And we've seen examples of all three types of threat actors using automated vulnerability detection in the past. Okay, so what's the existing risk of releasing automated vulnerability detection tools? So one reason why attackers have a sort of upper hand is that they benefit from the natural worst case asymmetry, which is that attackers only need to find one working exploit, whereas defenders must defend against all possible vulnerabilities in order to succeed. In addition, the existing risk of these models is heavily influenced by the resources of the attackers. So we've seen sophisticated attackers use automated vulnerability detection in the past to improve their attack design. And in particular, one type of such tool is called fuzzing tools, which have long been used to find vulnerabilities in software by both attackers as well as defenders. Okay, so what is the existing state of defenses, like absent the use of open foundation models? So I think one of the main things that defenses often rely on is defense in depth. What this basically means is that you have many defenses that are layered on different layers of your application stack. And this basically helps you ensure that an unaddressed vulnerability in one stack does not lead to a complete exposure of the system, but rather there are defenses in another layer that can compensate for it. Okay, so having looked at the existing state of affairs for cybersecurity, let's look at the marginal risk of these models. So we'll compare this both to existing tools, but also to closed foundation models like OpenAI's GPT-4. So it's true that closed foundation models can be better monitored for misuse. But at the same time, I want to stress that it's not really clear if these models can perform these detections in the same way. Or it's not obvious to me, or it's not obvious to us in our analysis, that closed foundation models will always succeed at finding out when these models are being misused. And the reason for that is because vulnerability detection is not necessarily a misuse of language models. So to stress that even more, let's take a look at an example. Here's my use of two different language models. On the left-hand side, we have ChatGPT that's using the GPT-4 language model. On the right-hand side, we have an open model, which is Llama 2. In both of these cases, I inputted a recent vulnerability that was found in an active software package and asked these models to find the vulnerability. Now, both of these models correctly identified the vulnerability. You can see the buffer overflow risk from ChatGPT, as well as the buffer overflow risk being highlighted from Llama 2. The key thing is that ChatGPT does not really prevent this request from going through. It's not really monitoring or stopping users from finding this risk. And that's because the model does not have the context of whether it is a developer of the system or someone who's using this model to fix this vulnerability, or whether it's someone who's using this model to hack into the system. So in other words, it's really hard to distinguish between legitimate and malicious use. And that's one reason why we don't think even closed model developers can do very much to stop this type of use of their tools. So in other words, it's really sort of not obvious in our analysis why the marginal risk of using a closed model is any lower than using open models in this case. Further, let's come back to the point about the ease of defense. I think one of the things that is underappreciated in many analyses of open foundation models so far is that language models can be incorporated into the information security toolkit to bolster the defense of software systems. So this is very similar to previous waves of software, For example, fuzzing tools have long been used by developers to sort of find and fix vulnerabilities before they release their software into the real world. And the same is true of LLMs. In fact, like we've already seen some examples of language models being used for security. And in particular, the key point to note here is that defenders of systems usually have much better access to the systems they're trying to defend compared to attackers. So they can deploy these systems before release. They have all the access to all layers of the infrastructure, and they can continue to rely on techniques like defense in depth. So here's one example of how language models are already being used for this purpose. So this is Google's Cloud Security Workbench. It's powered by their language model PaLM 2, and in particular by a security fine-tuned version of it called SecPaLM 2. I think it stands for security in PaLM 2. This type of model can be used for identifying malware automatically, rather than relying on humans to identify malware when it enters a system. Another example is fuzzing tools, which is an example of vulnerability detection I mentioned earlier. They're being improved by the use of LLMs. So this is another example from Google. Google has been using LLMs to improve the accuracy of their fuzzing tools. And this example in particular is from one of the most famous open source fuzzing tools, which is called OSS Fuzz, that continuously scans over 1,000 open source repositories. And then if it finds an error, it basically notifies the developers of the repository and asks them to fix the bug. And so we've already seen LLMs basically improving the accuracy of OSS Fuzz. And I think we'll see the trend continue as people start adopting more open models in basically reducing security threats. Okay, so coming back to the framework, the last step of our framework for cybersecurity is what the uncertainty and assumptions are. And in particular, I think we make some assumptions when we say that the marginal risk of open models will be low. The first and most important assumption is that defenders will continue to have much better access to state-of-the-art tools, including those based on open models. I think this is a big assumption because it assumes that we'll have a lot of investment by defenders in using these tools to update their InfoSec practices. Now, as we have seen for many past instances, people often do not invest nearly enough in the cybersecurity infrastructure. So this certainly is a big assumption on our part. But the key thing that we want to highlight is that the balance between offensive and defensive uses does not really change with the introduction of open foundation models. In fact, if anything, because of what we saw in the last slide, the balance is likely to tilt towards the offenders compared to the other way around. Our broader point, though, here is that the debate around the safety of AI is often sort of conflates two very different things. The first is how can we make models safe? But the second is how can we make systems safe? Or more broadly, how can we have societal impacts that are like moderated or basically mitigating the risks of these models? And here we think the AI community has committed a significant blunder by conflating AI safety with model safety. Our main claim is that model level interventions are useful, but they're not really the end of the world. I mean, we cannot rely on model level interventions at curbing most of the misuse risks. And this is true even if we consider model alignment solutions to work perfectly, because we can always use these models for dual use purposes. For example, as we saw with the initial example with cybersecurity, we can use GPT-4 for this type of dual use purpose. It's really hard to distinguish between legitimate and illegitimate uses because that relies on context that the model does not have. So the model does not really know if we are like a malicious user trying to exploit a software piece of software infrastructure, or if we are a developer trying to fix these bugs, and it cannot know that distinction. And so our main point, again, to reiterate, is that we cannot rely on model level interventions alone in order to ensure AI safety. We have to look downstream. We have to think about how we are defending our systems. We have to think about what the other requirements in other parts of the pipeline are, for instance, DNA synthesis screening for biosecurity risks, and so on. So based on this analysis and based on this insight, we offer a few different recommendations. The first is that defenses against misuse risk must primarily be located outside the models. So it's important to sort of keep doing some of the model intervention work that we're doing so far. But I think the AI safety community has misplaced a lot of its resources in focusing on model level interventions, whereas more of the resources should be, in our view, focused on defenses that are downstream, whether it is like DNA synthesis, as I mentioned, or for cybersecurity, it is increasing our investments in using foundation models to improve the cybersecurity from the defender's perspective. For researchers who are looking at the risks of foundation models, we also, basically emphasize that what is really the property at stake in a lot of these discussions is the marginal risk of releasing models openly. Otherwise, we'll continue to stay stuck in the loop where one side says, we can use foundation models to create pathogens, but we also at the same time find out that the same information is available on the internet, and we are basically at an impasse unless we start looking at this debate from a marginal risk perspective. What this also means is that because we think misuse risks primarily arise outside the models, a lot of the focus on red teaming of AI should also be directed towards the system level risks and for early warning, rather than for fixing issues in the models alone. And finally, and perhaps most importantly, a lot of the red teaming that has occurred so far has basically occurred by the model developers themselves. But we think this type of red teaming is best handled when you have people who are outside the company who still have aligned incentives. And so to that extent, I think the place for regulation or policy is not on restricting the release of open foundation models, but on providing the governance structure for releasing them responsibly. We are seeing some early steps towards this. We have the AI safety institutes in the US and UK, the National Institutes for Standards, the NIST Institute basically is doing a lot of work in order to come up with the standard for evaluating the risks of models. And I think this type of effort is likely to be much more effective at curbing the real risks of AI compared to restrictions on the releases of these models, at least in the present status quo. Okay, I'll end here. I think we have about 10 to 15 more minutes. I'm happy to take questions.
Thank you. Robert, over to you. Should I just first want to ask if Mike Nelson, if he was able to join? If not, then Robert, maybe we can proceed with the questions and answers. Mike, are you on the call? Robert, I think.
Yeah, I'm not seeing him.
Yeah, I'm not seeing him either. So yeah, why don't we proceed? As I understand, Robert, we can go ahead with some questions of our own, and we could also, if we have time, open the floor from some of the audience to ask some questions.
Well, first I want to thank Sayash again. Great presentation and very thorough. And Claire, it brings to me a kind of it's a kind of fun situation because, everyone is always very concerned about open source being more unsafe than actually closed software. And I'm going to ask Sayash, it seems to me that the fact that it's open and it's possibly perceived as higher risk, it invites further risk mitigation practices than the closed models. Therefore, actually, the open models foundation is probably safer, or actually tries to mitigate safety more diligently than the closed models. Would that be a correct assumption?
I think that's absolutely right. And I think this is not a new debate. So in the history of open source software, not just for open foundation models, in the early days of Linux, for example, I think a lot of concerns were raised about the security of Linux because anyone can essentially write code. And in particular, it was thought that because like for closed models, you cannot read the code, it's much harder to find vulnerabilities. This phenomenon was known as security through obscurity. So the idea was you can obscure the code systems and that'll lead to better security. And I think in the last 2 decades, security through obscurity has mostly been debunked. We have found that closed software is no better than open software. And in particular, I think one of the most memorable quotes from Linus Torvalds is, "Many eyes make shallow bugs." So basically his point is that because so many people can look at the code, it's much easier to find these vulnerabilities before they get too far. So I think the same holds true, as you pointed out, for the case of open foundation models as well. Precisely because so many people have access, I think we are much more likely to find and fix these issues quickly.
I also make another parallel. and this is going to the analog world. Rio is a very interesting city, beautiful city, squeezed between mountain ranges and the white sandy beaches. But it created a housing problem because of being a big metropolis. So you have a lot of the ghettos going up the hillsides. And you even have drug lords are hidden in these little hillsides. And there's nothing you can do about it. And talking to the public workers and the mayor and stuff, well, it's not going to eradicate anything at all here. You just have to learn how to manage on an ongoing basis. And it seems to me that AI, because of its rapid development, it's always an ongoing basis. It's going to be continuous mode forever, and looking at the safety aspect of it. So it seems to me that from what we see here today and what we have learned from all the tours that we have done, that AI is here to come, and AI is here to stay in our radar on a 24/7 basis.
I completely agree. I think that's a great point.
Yeah, Anders, Bruno, did you have any questions on the YouTube? I don't know if you're still there. Oh, that you're there. I see your.
Otherwise, I might have a question.
Yeah, Anders, I'll pass it back to you then.
Yeah. Okay. So
Sayash, thank
yeah.
you very much.
Yeah. Thank you very much. So Sayash, one of the things that you didn't touch upon in this presentation, but I think it relates to open source foundation models, which I'll be interested to know if you have any views on that, is as we have seen from many of the regulatory frameworks around the world, you mentioned specifically the EU AI Act. One of the things, one of the compliance requirements that will apply to both open and closed systems is the ability to abide by copyright directive and to be transparent about the source of their training data, whether any of that is copyrighted and so forth. Do you have any views on whether open source models will be able to comply efficiently with these kind of frameworks, or if not, could this have an adverse effect on open foundation models being able to operate in markets like in the European Union?
That's a great question. So I think, first of all, I completely agree. I think being able to comply with the directive is hard, simply because the data sets that are used to train a lot of these models are usually immense. That said, I think, as you mentioned, what's required here is not like a complete list of every single sort of website you scrape, but it's like at a slightly higher level, right? Like, so it's transparency at a slightly higher level into what goes into the models. And in particular, I think if like past status quo is anything to go by, open models might actually have an easier time complying with this regulation. So here's what I mean by that. So I think one of the models that I highlighted in my presentation was GPT-NEO-X from Eleuther AI. The dataset that GPT-NEO-X was trained on is perhaps the most well-documented dataset that's used in AI. It's on the larger side. I think it is an 800 gigabyte dataset, which has been used to train this like quite performant large language model. And I think apart from like this specific data, we have very few sources of data which are such well like documented examples. Now, what happens in status quo is that people who create such data sets are at a natural disadvantage because they're basically very transparent about what's in the data. And that also opens up like potential legal liability concerns. And that's one of the reasons why many closed providers or commercial providers have not made the sources of data they use for training available. So if anything, I think directives on the transparency on data would actually level the playing field somewhat, because closed model providers would have to also give inputs on what data they use to train their models, which is not really something that any of these closed models are doing right now. Like, we have no transparency into what data ChatGPT is trained on, whether it's GPT 3.5 or GPT 4. Similarly for Google, for Meta's Llama 2, as I mentioned, I think it really is like a perverse business incentive to sort of not reveal what data is being used to train the model to shield yourself from liability concerns. And I think, if anything, directives on transparency sort of level the playing field between like smaller actors like Eleuther AI and larger tech companies.
I think that's a great explanation, and I appreciate that. Robert, if you wouldn't mind, I have one more question I would like to ask, if you have time.
Please,
Yep.
go
So
ahead.
another thing that you didn't really touch upon in the presentation, but that it is talked a lot about, one perceived advantage of open foundation models is the perceived ability to boost a competitive landscape in the AI sector, specifically equalizing the marketplace for SMEs, upstarts, people, companies around the world, outside of Silicon Valley, to more effectively innovate and to compete against these larger closed based systems. Do you have any thoughts about that?
Absolutely. I think this is one of the most sort of critical advantages of open foundation models is like avoiding this type of concentration of power and enabling a more competitive market. So in particular, I think like at the foundation model level of the stack, that is definitely true. People who are like don't have the resources to train their own models can use these models off the shelf and fine tune them for their own use cases. So it's better for like competition and for innovation. At the same time, like one thing I will highlight is that the foundation model stack does not just consist of the models themselves. So far in this presentation and in our work, we mostly focus on the foundation model layer of the stack. But if we go one step below this like model level on the stack, the next thing below it is the need for compute to train these models. And I think that's one place where foundation models released openly is not really enough to sort of enable more competitiveness and to sort of decrease the concentration of power. Because essentially every single major player, whether it is an open foundation model developer or a closed one, is relying on the same cloud service providers. They're relying on the same manufacturers of GPUs, mostly NVIDIA, in some cases AMD. And so while I agree that like competition and decreasing concentration of power are benefits of open foundation models, I think there are benefits that are isolated somewhat to the layer of the foundation model stacks and the downstream markets, but they're not really sort of percolating to other layers of the stack, things like creating GPU chips or training infrastructure or cloud service providers. And so I completely agree with the statement that foundation models increase competition. The only asterisk I would put on that statement is that they do it for the foundation model level and the downstream providers, but these benefits don't really percolate to other layers of the stack, specifically compute.
Yeah, perhaps with the exception that there's some evidence that I've been seeing. It seems to show that many open source foundation models are able to more effectively train on smaller data sets, and so may require less compute to develop competing models. Is that something that you would agree with?
I think that's true. Many open source models require less data, but the compute they're using still belongs to one of the big two, like AMD and NVIDIA chip companies. And basically, we have no alternatives at present to this sort of duopoly in the GPU chip space. I think Google is the third sort of entrant. They have the TPU series for training models specifically. But I think apart from these larger companies, the capital costs for setting up like entering this market are so high in terms of specifically the chip fab like layer of the stack that I think concentration is really an issue at this level of the stack. And I don't think foundation models have been able to do much so far to curb competition there.
Yeah, I mean, just a couple of days ago, we saw in the news that Microsoft and OpenAI plans to spend $100 billion on setting up a supercomputer by 2028. And that's kind of mind-boggling, and how to compete against that is certainly a huge issue. Dan, I see you online. Did you have a question?
Yes, thank you, Anders. Thank you, Sayash. I have a question. It's fascinating to listen in to the work you've done. My question relates to the differing layers that make up an ecosystem. Just as Apple has its famous or infamous, depending on how you look at it, walled garden ecosystem for its iPhones, its Macs, etc., and then Windows or Android comes in with a more open model. Whereas with AI, I think we are in the early stages of looking at an ecosystem being formed, whether it is at the chip level, the compute layer, as you say, the cloud layer, the foundation model layer, or even higher layers. So if your recommendation, and I've seen as well that recently in January, the Commerce Department is now asking for cloud providers to basically inform it if there are foreign governments or foreign entities that are using the American cloud providers to train their models. So suggesting that at some point there could be an effort to also deny the availability of these services to foreign actors. My question then is, how useful is it to then deny the openness of what layer, and how do you then protect against something that is that could potentially go open all the way, or even at just differing layers of this ecosystem?
Yeah, that's a great question. So I think we've already seen, as you mentioned, some attempts to control things at the cloud provider layer or the chip layer. I think the most notable is the export controls on lots of GPU chips above like a certain specification. So one of the things that like the US has done in the last year is really restrict the sort of top tier chips from being sold to countries like China, I think, in particular. And so as of today, I don't think NVIDIA can export their top of the line H100 or A100 GPU chips to China. Now, NVIDIA's response to this was like, I think the very next day or maybe within a week, they sort of tweaked all of their chips to be able to be able to like sell them in China, basically just below the threshold set by the US government. And essentially this shows that like there is certain amounts of adaptability, but also I'm not sure about what the intended sort of end effect of these export controls is and how likely they're to be successful, simply because I think foundation models are not like nuclear technology. I mean, everyone in the entire world has the know-how of how to build them. I think most places, including like other nation states, other research institutions, have ongoing efforts to build their own models. In some cases, the foundation models coming out of China and like other countries across the world are more competitive compared to the foundation models in the US. So I really don't see any sort of like clear benefit, at least as of right now, in terms of this type of restriction. But that said, I think a lot of this has to do with like what the other geopolitical considerations are, and that's not really my area of expertise. But talking specifically from the perspective of AI, I don't think it is likely to make a material difference as to whether the US allows the export of NVIDIA chips to other countries on that country's AI ecosystem. If anything, I think the ecosystem will be more robust to such interventions because it'll have to come up with its own homegrown chip industry. So to me, I think a lot of these like don't make sense from the perspective of AI safety. Regarding the other geopolitical considerations, yeah, as I said, I don't think I'm an expert, but from an AI perspective, I'm not sure if it really helps.
So as a follow-up on that question, then, do you see at some point the creation of a wall ecosystem, which is more closed, and who will be the winners therein, and then perhaps a more open one, and the winner and leaders in that area?
Another great question. So I think as of right now, I don't see that happening. Like in contrast to the Apple ecosystem, where you have like a specific app store, and the app store, as soon as it was launched, it just basically took off. We've had an attempt at that. OpenAI launched its own app store for custom GPTs, and that has not really got as much traction. So it seems like the way to go for developers for now is to be developer or model agnostic, so that as soon as you have like foundation models that are higher in capability, they can basically just switch out one model for another. One example is Anthropic's Claude 3 that recently I think beats GPT-4 after a year of dominance on like many of the major benchmarks. And in response to that, many application developers chose to switch away from GPT-4 as the foundation model of choice. And I think this type of trend would continue. Like I think developers really are seeing these models as like comparing them on their own terms rather than trying to live in the ecosystem. Like if OpenAI had launched the GPT store and we would have like seen its enormous growth today, I might be giving a different answer. But so far, we have not really seen that trajectory. So far, I think developers prefer to be model agnostic or model provider agnostic when it comes to the application layer of the ecosystem.
Right. Thank you.
If we have time, I got one final question, Robert. Do you have any other questions before?
No, please go ahead, but be last because I need to move
Yeah.
on.
Yeah. So
At the
very
airport.
last question, and this is just one of the things we talked about earlier were some of the constraints that the open financial models. One is regulatory uncertainty. The other one is in real impacts of lack of access to compute and so on. So it's a two-part question. Are you optimistic that open foundation models will remain competitive with closed systems? And what can governments do to support the open foundation model sector?
Yeah, both great questions. So I think oftentimes within the AI community, we have a tendency to fixate on the best possible metric. So, I mean, when we're looking at benchmarks, I think as a culture, people in the AI community just look at the most performant models. And going by that metric, I think open models have never been competitive with closed ones. So GPT-4 has been basically the best model for the last year or so. And I think right now, most people agree that Anthropic's Claude 3 is basically the best model on the market. And so I think maybe that will continue to be the case. We're yet to see. I think Meta is putting out like a very strong Llama 3. At least it's expected to open source a model that's competitive with GPT-4, but that's still speculation. But if we change the metrics slightly, if you're not just looking at like the best model, which does the best on every single metric, but rather we are looking at case-specific applications, then it's no longer clear that open models are like worse or better than closed ones. So here's an example. Like sometimes what we want is a model that can run locally or on your own computer without access to the internet. And there we don't really concern about the best possible, we're not concerned about the best possible performance, but rather what is possible within the constraints of this computing infrastructure. And here, a lot of the models that we've seen released, the ones that work best at least, are models that are open. So Mistral 7B is this model released by French AI company Mistral, which really outperformed all of these other small models at the time of its release. Similarly, if we look at text-to-image models that can run locally, again, it's an open foundation model that sort of takes the crown. And we have similar results for text-to-speech systems in all sorts of other domains. So I think if the question is about like the top performing models, I do think the trend will continue to hold at least for some time because these top models cost such a lot of money to create. There are like high capital costs as we discussed. But if you're talking about like what's the best model in a given setting, whether it is for local devices or for like smaller tasks like text-to-speech or even text-to-image, I think open models will remain a lot more competitive over time. In terms of what the government can do to support the development of this ecosystem, I think one of the most promising efforts is the National AI Research Resource, or NARE, in the US. My apologies, I'm mostly familiar with the US tech policy ecosystem. So a lot of the examples I give will be from here. But the NARE, the National AI Research Resource, is basically an effort by the US government to democratize access to AI technology because it realized that there are these high capital costs required even just to clear the bar for entry. And I think it wanted to counter that a bit. So I think a pilot of the NARE is already live. It allows people from academic institutions and nonprofits to be able to train AI models and systems openly and to be able to do scientific research using these models and using the government's infrastructure. And I think this is a very promising effort from the US government. The pilot is live. I think the full act has not yet been passed as far as I understand. I mean, conditional on it being passed, I think this is on the right track in terms of what the government can do.
Thank you.
Very good. It was a great class, wasn't it, Anders?
I thought it was wonderful. It was very enlightening.
Yeah, I could stay on. We probably have to do a second one. Unfortunately, I have a plane to catch. But Sayash, again, thank you very much. You shed some great light on many issues that we've been finding out about. And yes, we're looking up now to the model war, it looks like, coming up. So again, in behalf of WITSA, thank you very much for your participation and contribution. We hope to stay connected as we are going to be consistently and constantly focused on propagating the AI endeavor. And yes, I want to also thank my colleagues, Anders and Dan, and Aslina is here as well, and everyone here on the audience. Thank you very much for your time, and I'll see you next time around.
Thank you very
Thank you.
much.
Right. Thank you so much for having me.
Bye-bye.
Appreciate it. Thank you.